All right, so let's begin talking about this idea of Lewis theory. So I'll remind you that this is the simplest theory to describe chemical bonding. And the reason it's so simple is because it's very qualitative. It can be done on a scrap of paper, on a napkin. You can just draw them on your notes. Something we need to remember before we get started is we need to remember this idea of valence electrons. So remember, these are the electrons that are in the outermost energy level. They're the ones that are going to participate in bonding. And we were able to look at electron configurations or look at the periodic table and decide what these valence electrons were and how many of them there were. If you're not able to remember that, please review chapter 8. Or you can ask me always. Okay, so in Lewis theory, we need to look at valence electrons to describe bonding, and the way that these valence electrons are going to be represented is by dots. So simple enough, we're going to count them and we're going to draw them as dots. So when we want to draw a symbol in Lewis theory, okay, so a Lewis theory symbol, we're going to write the letter for the element from the periodic table, or its chemical symbol basically, and then we're going to draw dots around it representing the valence electrons. So it's going to be, once again, let me write it here, it's the element symbol from the periodic table, and dots for the valence electrons. So let's do an example. So let's look at oxygen. So oxygen, the atom, we know its electron configuration from the periodic table. I'll just write it here, 1s2, 2s2, 2p4. So based on its electron configuration, we can see the valence electrons are in the n equals 2 level. So there are 6 valence electrons. And the Lewis symbol is the following. So here's O, and surrounding the oxygen, we're going to put the 6 valence electrons represented as dots. So 1, 2, 3, 4, 5, 6. So another thing we're going to need to remind ourselves of when we're thinking about this Lewis theory is this concept of the octet rule, which we have discussed briefly. So the octet rule simply states that a full outer shell for an element is 8. So as a reminder, there actually are some exceptions to that we're going to look at in a little bit. So just keep in the back of your head, there are some exceptions. For example, hydrogen. We know hydrogen's not going to want to have 8 electrons. So this theory can be used for both covalent and ionic compounds. It's best for covalent compounds, but of course you can use it for ionic as well. And we are going to do examples of each in the next video.